Okay. So with number 4, what we had said yesterday was to fill in the blank with a numerator or denominator to make the number sentence true. And we said that 7 times something to make 7 less than 7. Well, then this numerator could be 1, 2, or 3, because this fraction needs to be less than 1. It needs to be something less than 1. Do you have a question, or are you answering something? Okay. Because if I do 7 times 4/4, then it would be equal to 7. So I need this to be less than 1. Just like our lesson that we were doing yesterday. So this needs to be less than 4. So that's why it's 1, 2, or 3. So for 7 somethings times 15 to be greater than 15, we said yesterday, this is all going over yesterday, that this needed to be 6, 5, 4, 3, 2, or 1. Yes? Okay. Because this needed to be an improper fraction. Because this needed to be greater than 1. The fraction needed to be greater than 1 to make 15 bigger than 15. Now, go back and watch yesterday. I don't want to go through it, but so then 3 times something to be equal to 3. And then what did the numerator need to be? 5. Because 5/5 was equal to 1. 3 times 1 is equal to 3. So in here, to look at the inequalities, choose a single fraction to write in all 3 blanks that would make all 3 number sentences true, and then explain how you know 3/4 times something to be greater than 3/4. So this is my first factor. This isn't my scaling factor. You need to put in a scaling factor. They put it in a different order. So these are the numbers that I'm comparing. You need to put in a scaling factor. So basically, you had a lot of leeway with what you put in here. But what did it have to be? There was one thing that it had to be, Jonathan. It had to be greater than 1. It had to be an improper fraction. No matter what you put in there, it had to be improper. No matter what. It had to be bigger than 1. So no matter what it is. Now I know that last year when I taught this, I had some people that really wrote some really wackadoo numbers because they were just like, oh, I'm just going to go way out there and I'm going to try to impress Miss Strickland, and they wrote some really weird things, and then they ended up getting it really wrong because they were trying to write some really, really large numbers. Don't do that. Keep it simple, because the more out there you get, the more likely it is you're going to mess it up. Keep it simple. I mean, why not just do 4/3 or something? 5/4. 6/5. Why do you have to do 100,000 over 99,990? Why? I'm not impressed, because then you're likely to get it wrong. So keep it simple. 2 times something greater than 2. So, Nardo, what did you put there? What improper fraction would you put in there? I know, it's fine. What improper fraction could you put in there? I'm not upset. What would you put in there? You could put 5/4. What would you put, Bailey?
I put 3/2.
3/2. I mean, keep it simple. 7/5 times something greater than 7/5. Caitlin, what would you do?
I put 4/1.
As long as it's improper. Now I would, yeah, if it's greater than 1. I would probably steer away from the whole number thing. But 3/4 times something is less than 3/4. What would you put in here? We need to make it less than. So what rule would we need to follow here? What do we need to follow here, Daniel?
Make it less than.
Make it less than 1. So what could you put here, Alora? Less than 1. Three six. Is that less than 1? Yeah. 2 times something less than 2. Serena, what could you do? One half. 7/5 times something less than 7/5. Jacoby? 1/3. As long as it's less than 1. You can do 9/10. It's close, but it's not 1 whole. Johnny says multiplication always makes numbers bigger. Explain to Johnny why this isn't true. Give more than one example to help him understand.
2 times 1.
Huh? What times 0? You can do better than that. So, if multiplication always makes numbers bigger, what if I have 100 times 1/2? What do you get? You get 50. So does it always make numbers bigger? No. It depends on what you're multiplying. A company uses a sketch to plan an advertisement on the side of a building. The lettering on the sketch is 3/4 inches tall. In the actual advertisement, the letters must be 34 times as tall. How tall will the letters be on the building? So what would you do to solve this problem? So 34 times as tall as 3/4. Do you agree that that is how you would write it? On the paper, they're 3/4 of an inch. And in the advertisement, the letters must be 34 times as tall as 3/4 of an inch. Jonathan disagrees. That's fine. There's nothing wrong with it. So you would think that it needs to be 3/4 times 34. So how do you think I would write it? But it's implied it's there. I just didn't write it. I thought you meant like you thought it needed to be the other order, the other way around. Okay, so this going with, do I really, I'm going to go to the strategy that I showed you yesterday. I'm a little bit lazy, and I claim it with pride. I don't want to multiply 34 times 3 and then divide that by 4. I'm going to do my cross simplifying. Do you have to do that? No, I'm just doing it because I already see that I can. I know that 4 can't go into 34. I know that. 4 goes into 32. But I know that there's a number that can go. Now, again, if y'all don't get it, just don't do it and do the multiplying and the dividing. Is there a number that can go into 4 and 34? What is that? 2. Because they're both even. So 2 goes into 4 2 times. 2 goes into 34 17. I'm just making it smaller so it's not quite so large. So then I have 17 times 3, which is 60. I was able to multiply that in my head a little bit easier than 34 times 3. Because I know that that's 21. That's fine. Let's see. So that's 21 over 2. I still have to divide it, but it's not quite as easy. I know. I got distracted. I guess I don't need to worry about doing decimals. So it's 25. I wouldn't do remainder 1. I would turn it into a fraction. So 25 and 1/2 inches tall. What? Okay. So this is your whole number. This is your numerator. Because it's you have that improper fraction. So we go from an improper fraction to a mix. Paper chart. Thing's been up there. So it's whole number, numerator, denominator. So whole number, numerator, denominator, and then yours just has to be simplified. So 25 and 1/2 inches tall. So I want to think about, would it make a difference if we put it in the other order of 3/4? I'm just curious. 3/4 of 34. I want to see if it makes a difference, because sometimes if you do numbers in the opposite order, if it matters, and you're saying no, it doesn't matter. So because when you're multiplying is just like adding. 2 plus 3 is the same as 3 plus 2. 2 times 3 is the same as 3 times 2. So it shouldn't matter. Yeah. Okay, good. So because sometimes the order in which you do it really does matter. So good. I'm glad to know it doesn't matter. So when I looked at it, I was like, this doesn't matter. Jason is drawing the floor plan of his bedroom. He is drawing everything with dimensions that are 1/12 the actual size. Because if you're drawing your bedroom, your piece of paper can't be the actual size of your room. But sometimes you'll see a map and it'll say, this is not to scale, meaning it can't be, the actual size. 1/12 the actual size. His bed measures 6 feet by 3 feet. And the room measures 14 feet by 16 feet. What are the dimensions of his bed and room in his drawing? So what would you actually do to solve that problem, or what did you do to solve that problem? If his bed measures 6 feet by 3 feet, what would be the measurement, the actual full measurement of his bed? So his bed is 18 feet. So if they're doing on his drawing, it's 1/12. Because we have 6 times 3. That's when you're doing this by, means that you're going to multiply. That's not a 5th grade skill. That's an old skill. That's probably what, 4th grade? That's old. That's way old. Length times width. So if it's 1/12, 1/12 of 18. Then you have his room was 14 by 16. What is the measurement of his room? You need to figure that one out. Do that. What was it? 224. So it's 1/12 of 224. So I'm hoping that if you didn't do this, you're writing it down, or you're just checking to make sure that you did it. So I see what Nardo did, and he just did 1/12 of 6, 1/12 of 3, 1/12 of 14, and 1/12 of 16. So I see where some people did both, where they did, you know, like the area of both, and then like the area of the full measurement or the area of the dimensions. So if we did the of the full area, you would have, that would end up being 1.5. Wow, 224 over 12. So I could see merits in either one of doing all of the measurements. It's a whole lot of work. Doing all the dimensions. If you do 1/12 of 6, so that would be 1/2 of a foot. Is that what you got for that one with the 6? And then if you did 1/12 of 3, 1/4 of a foot for the bed, that would be the dimensions of the bed. and then 1/12 of 14. 14, 12. I'm doing the way some of the other ones did it. 1 and 2/12, 1 and 1/6 of a foot for the one dimension, and you would have 16/12, 1 and 4/12, 1 and 1/3. So if you did the full area and then took the 12s, that was what you get. And if you do each dimension, which it did ask for the dimensions, so I would assume that maybe with the red is the way that you were supposed to, because it did ask for the dimensions. But I wouldn't fault you for doing the area, because that's the way I would have done it first, and then with reading it, really reading it, going, oh, it asked for dimensions. So that's really what it was asking for, is the dimensions.